Welcome back, learners, and let us begin with our first concept. So our first concept is on the particle model of matter, and in that, as I've said, we're going to be looking at the properties of solids, liquids, and gases. So it is important to note that when we are talking about the particles, no one has ever seen the particles. However, we're going to try to use this model to explain their behavior, their movement, and how they interact with each other and the environment around them. And it is important to take note that atoms and molecules are referred to as particles in the particle model of matter. So when we're talking about this model of the particle model of matter, the particles are actually the atoms and the molecules. And we know that we have never seen those things. So we need to try and explain how they behave and how they interact with each other by using this specific model. So now, the particle model teaches us that all matter is made up of tiny particles. Remember that those tiny particles are your atoms and molecules. Number two, the particles are always in a constant motion. So the atoms and the molecules are always in a constant motion. The temperature, which is energy, affects the speed at which these particles move. So the more the energy or the more the temperature is increased, the motion or the movement of these particles, being the atoms or the molecules, also increases. So the movement depends on the energy or depends on the temperature. Number four, the particles have forces of attraction between them. So these particles are not just existing, they have forces of attraction that are keeping them in a set place. Then number five, there are empty spaces between the particles. So between one particle and the next particle, there can't be any other particle in between, or any other atom or any other thing. That's just the force that is attracting the two particles and nothing else. So now, to get into detail of these things, the particle model is based on these four things. Number one, the arrangement of the particles. So when we're talking about these particles, we're going to be referring to the arrangement of the particles, the movement of the particles, the spaces between the particles, and lastly, the effect of the forces between the particles. So these particles, we're going to be looking at them at macro level, that being the solids, the liquid, and the gases. So starting with the first one, our solids. So the particles of a solid are tightly packed. That's very important to note. They are tightly packed in an organized pattern. As you can see from this picture, the particles, these particles are of a solid and they are tightly packed in an organized pattern. They vibrate on a fixed position. So as you can see from this picture here, the particles are vibrating. They are not stationary. They are always in a constant motion, as the particle model of matter says. Then also, the solids have a definite shape and volume, and as we can see from this picture, there is a specific shape that we can see. It looks more or less like a rectangle, and they are in a certain volume of that space. They also have small spaces between the particles. If you were to look very carefully on this picture again, you will notice that between one particle and the other, there is this tiny, tiny space between them. And then these particles are held together by a strong force. That strong force is your attractive force. So these particles are not just standing there, they are not just there in that pattern. Those particles are held together by the attractive forces. And in a solid, those forces are strong forces. Now moving on to our next property, which is now the properties of liquids. Now liquids are different from the solids. How are they different? They are different in a sense that the particles of a liquid, they are loosely packed together and they are far enough to slide over each other. So they are not as tightly packed as they are in a solid. They are loosely packed, and that enables them to slide over each other. They move past each other in random directions. So liquids are not going in a specific direction. They can go up and down, left and right in a random direction. Also, liquids take up the shape of the container as they have a definite volume. So if you were to take a circular cup and pour water there, the shape of that water is going to take the shape of the container. However, if you take a rectangular cup and pour the same water again, now the water is going to be in the shape of a rectangle. So that means that the liquids, they always take the shape of the container and they have a definite volume. D, they have small spaces between them. However, the spaces are bigger than those of solids. So now still in the liquids, you cannot be able to see them, but then there are spaces between one water molecule and the other water molecule. And those spaces are small, but then they're slightly bigger than those of a solid. And then the last property of liquids is that the force that holds the particles together is weaker than the force between the solid particles. So both the liquids and the solids are held together by attractive forces. However, the forces that are holding the liquid particles together are slightly weaker than the forces that are holding the solid particles together. Now, looking at our last state of matter, being the gases. Now, how different are the gases from the solid and the liquid? First of all, the particles of a gas have no particular arrangement. They are just on a random arrangement in a particular container. They move freely around and very quickly fill any space that is available. So as you can see from this picture, they are in a certain container, but then they filled the space because they are moving freely within that space. And on this picture here that you have, you're seeing the gas particles moving around freely within that given space. Also, the particles of gases have an indefinite shape and volume. So you can't really say that when you have gas particles in a circular container, that the gas particles, they will have a circular shape. They will have an indefinite shape because they are just moving randomly within that space. And also now, there are very large spaces between the gas particles. So the spaces between the gas particles are larger than the spaces that are between the solid particles and the liquid particles. And then lastly, the force of attraction between the gas particles is very, very weak. So now, if you're to compare the forces between these three states of matter, solids, they have strong attractive forces that are holding the molecules together. In a liquid, the force that holds the molecules together is slightly weaker than the forces holding the solids together. However, in a gas particles, those ones, they have the weak force that is holding the gas particles together, which now that enables those gas particles to move around the space and fill the entire space. So with that said, we are now going to look at how those particles behave when we are either adding the energy or when we are removing the energy. We need to know when we have a solid, a liquid, or a gas, how do those particles making up that matter behave when we are adding energy or when we are removing the energy. But before we do that, we're going to quickly take an ad break, and I will see you just right after this.